Hello everyone. In this video we'll look at finding the area between two curves. So to find an area between two curves, we should first find out where the two curves meet, which determines the endpoints of the integration. We can divide the area into vertical or horizontal strips and integrate. So there are actually two cases that we are going to be looking at. In the first case, like this one here, let's say that we have fx and we do have this function gx. They both are meeting at these 2 points. This is going to be A and this is going to be B. We need to find the area of the pink area in between the two functions. Well, in this case, we clearly can tell that the function fx is above the function gx, so it is above. So the function fx is greater than or equal to the function gx. In this case, the area will be the integration from a to b, where both functions are meeting, for the big function minus the small function dx. In the second case is almost identical to the first case. However, here we are going to determine the area between fy and gy from C to D. And why I'm saying that? Because if I go vertically, I will notice that this part all the way to here is basically an area bounded by the same function. This function is the same as this part. So we are not going to do that. Instead, we are going to go horizontally, in which if you take any point here and you go horizontally, you are going to touch this function from this side and this function from the other side. Going horizontally means we are not integrating for x, we are integrating for y. So let's say that this function here is fy and this function here is gy. And we're going to integrate from this point all the way to this point here. So let's say that this point is C and this point is D. So I'm going to go the integration from C to D, and usually in the previous case we were going from up minus down, the function that comes up, and then minus the function that goes down, where in this case we'll go from right all the way to left. So which one comes in the right side? That's fy minus and then gy and dy. And the reason why we are going to go from right to left, because while you are going to the right side, x values are increasing. So the x values to the right are greater than the x values to the left. In the previous case, we go up minus down because the y values when you go up increase. Okay, let's look at this example. Find the area of the region enclosed by the parabola y equal to minus x squared and the line y equal minus x. By looking at these two, we will notice that you can go vertically anywhere, and you will notice that the green curve is above the blue one. What does that mean? We are going to integrate for dx. So I'm going to go here and say it's the integration from A to B. Where's A? You need to find these 2 points. It's clear that this is -1 and this is 2. So it's going to be from -1 to 2. That's the area. Okay. And now the big function, which is the one above, that's x, 2 minus x squared. Then minus gx, which is going to be this one, -x minus x, and that's going to be all dx. And now it's time to integrate. So it's going to be 2 minus x squared plus x dx, which is equal to 2x minus x cubed over 3 plus x squared over 2 from -1 to 2. Now you need to go back and substitute first by 2 and then by -1. So now it's time to substitute. So we'll substitute 2 first, then minus. We'll substitute now the negative 1. And then when you substitute, you're going to get an 4 minus 8 over 3 plus 4 over 2 minus negative 2 plus 1/3 plus 1/2. Altogether will be 9 over 2. This is going to be my area under the two curves, 2 minus x squared and negative x. So for this question here, we need to find the area between y cubed and y squared. Well, this question can be done in two different ways. You can consider the green function here above the blue function. So you are basically integrating with respect to x, dx. Or you can go horizontally and do it with respect to y. So since I did the previous one vertically, I'm going to do this one horizontally. So I'm going to be looking horizontally. So the blue function minus the green one, because the blue function goes on to the right side. And I am integrating with respect to y. So if I will do it with respect to y, I have to have x equal the function y. In this case, I'm going to start with y squared minus y cubed dy. Now, the points in which both functions are meeting with respect to y is going to be from 0 all the way to 1. Now, it's basically, if you integrate for x or y here, it's not a big difference because we have 1, 1 and 0, 0. That's going to be y cubed over 3 minus y to the power of 4 over 4 from 0 to 1. And then it's going to be 1 cubed over 3 minus 0 and 0. That's going to be 1 over 12. So the area will be 1 over 12 unit squared. Now, if you try to do it differently by going vertically and integrate with respect to x, you will do from 0 all the way to 1. And then which function goes up? Comes up, the green, but we need it to be y equal. So what I'm going to do here, I'm going to take the third root for both. So this is going to make this y equal a third root of x. So third root of x minus, and then for this one, you're going to take a square root for both. That's going to make this y would be equal square root of x, so square root of x dx. And if you integrate it and substitute from 0 to 1, you will get 1 over 12 as well. Now this question here, we basically, if you look at this question, you will notice that I have two areas, this one and this one. So what I'm going to do, I'm going to divide it into two parts. I'm going to call this A1 and A2. I'll do it separately and then I will add the areas. So let's start with the one on the left side, which is A1. Now you can do either way. You can look at the blue function and it's basically below the green. So this is up and this is down. I'm going to integrate vertically, okay, with respect to x. So I want to integrate with respect to x. If you look at the blue function, it's basically this one. So that's my blue function. This is my green function. So the blue came on the top of the green in the A1. So I'm going to say 2x cubed minus x squared minus 5x minus, and now the green, which is negative x squared plus 3x, and now dx. So now what I'm going to do, and then it's basically from this point all the way to this one. So this is basically, when you look at the x, this is going to be -2 and this is 0. So now I'm going to integrate. Oh, first, before, I'm going to simplify. 2x cubed, and then I have -x², and then negative times negative is positive. -x², positive x² is 0. They cross each other. Finally, -5x, and then there's a negative goes here, so -3x is going to be -8x dx. Now it's gonna be easier for me. Sorry, my bad. I will integrate, so it will be 2x to the power 4 over 4 minus 8x² over 2, from -2 to 0. And this is basically simplifying. Now that's going to be equal. When you substitute by the big one, which is 0, you will get 0. So 0 minus, well, it's going to be substituting by -2. And that's going to be equal to 8. Now we are going to integrate, find the area of A2, and then add it to this number here. So now we are going to start with the second part, which is A2. So A2 basically equal to the integration from this point all the way to this point here. Again, I'm going to look vertically, and the reason why, because it's very clear that the green is above the blue now. So if this is the blue and this is the green, so it's very clear that the green is up, so it goes first. And again, if you switch them, you're going to get a negative answer where you should go back and switch. Minus, and now the blue, dx. Now let's simplify, and then it's going to be from 0 all the way to this point here. In the x-axis, it's 2. That's going to be equal to 0 to 2. Now -x², and if you expand, you'll get positive x², so these two will cross out each other. I do have -2x cubed here, from here, and then from the other side I do have 3x, and I have, if you multiply by negative, it will be positive, so positive 8x. And now you can integrate. That's going to be negative. First, you are going to substitute by 2. That's going to be -2 to the power of 4 over 2 plus 4, 2 to the power of 2. And then when you substitute by 0, that's basically 0. So that's going to be equal as well to 8 as well. So now the area is going to be equal 8 plus 8, which is equal 16 units squared. Finally, this question here, find the area of the shaded region that is bounded by the curves y equal 2, the secant squared, and finally 1 minus x squared. So as you can see, you have 3 functions. If you look at the shaded part, the yellow part, you will notice that I can divide it into 2 sections, this one and this one here. Why did I decide that? Because by looking at this part, you will notice that it has been bounded by this line, y equal 2, and the secant squared. Green is not here. So what we're going to do, I'm going to call it A1. By looking at the second part, you will notice that we are talking about this line here, y equal 2, and the green, which is 1 minus x squared. So I could call this A2. And I'm going to integrate each one of them separately, then add the areas. So A1 is going to be equal the integration. Now, I could go, can you go horizontally? No, you can't, because we're looking at the area in between this and this. So what we're going to do, we'll go vertically. That means we are going to integrate for dx. So I could say this, since this function is above this one, so this is going to go first. So I'm going to say 2 minus secant squared x dx. And the integration is going to be from this point here, which is negative pi over 4, all the way to this line here, which is 0. Now, the integration of this is going to be 2 is going to be 2x, secant square is tangent, and then you will substitute from negative pi over 4 to 0. Now, by substituting, you are going to start from the 0, minus, and then that's going to be tangent 0 is 0, and this is 0, so this part is 0, minus, and now tangent negative pi over 4 basically is negative 1. So that's going to be equal to pi over 2. That's positive, right? So, and then you will expand the negative. Pi over 2 minus 1. That's going to be the area of A1. Now we are going to calculate the area of A2. Now for the area of A2, we are going to say A2 equal the integration. Now again, we are going to go also vertically, because we want the area bounded by this line, this function, and this function. So we're going to say by looking here, you will notice that this is the y over 2 is y equal to is above 1 minus x squared. So we'll go first. And then we are going to take it from the 0 all the way to 1. And now we can first simplify. It will be 2 minus 1, which is 1. Okay, and then the negative will go here. It's a plus x squared dx. We can right away integrate. That's going to be x plus x cubed over 3 from 0 to 1. And again, we are going to start from 1. 1 cube is 1 minus, and now 0 plus 0 cube over 3. This part is already 0. 1 plus 1/3 is 4 over 3. So this one here is 4 over 3. Now it's time to add these two areas. So I could say pi over 2 minus 1 plus 4 over 3. And that's going to be equal to pi over 2 plus 1 over 3. Okay, you can keep it like this, and that's going to be square unit. Or you can find it, if I ask you for an exact value, I would prefer to keep it like this. Or you can say 3 pi plus 2 over 6. And if you try to find it by using the calculator, you will get 1.904 square unit. So that's everything, guys, on this lesson. Please let me know if you have any questions, and see you in the next video. Bye bye.